It does not have to look through every single item. It just has to keep looking, you know, at a level and then go to the next level until it finds the number. And since we have these levels, we're talking just about a handful of jumps instead of, you know, thousands or millions depending on the data. So hopefully you thought that was pretty cool. I really love this example. So this is a little more accurate to what a clustered index structure would look like. Still, to make it more accurate, I would probably have to have arrows going every which way, but I just want to keep this nice and simple, as I said at the beginning. So there are a couple different sections on my index. The very bottom is called the leaf level, and everything above that is called the non-leaf level. It's kind of like an upside-down tree, and I've actually seen some presenters who reverse this and actually show the leaf levels on the top to make it more like a real physical tree that we might see. So basically what this means is that in the non-leaf levels, what we have there is what's called a clustered key. So when I create a table and decide I want a clustered index on it, which is going to be 99% of the time, that I have to decide on a cluster key. I have to decide what the key is going to be. Most of the time, not always, that your primary key will also be your cluster key. There's no hard and fast rule that says that has to be. But if you don't specify when you're creating the table and you say I want a particular key to be the primary key, SQL will automatically create a clustered index on that. You have a lot of options. You can override that. So probably because it makes sense in many cases, and also because that's the default behavior, you almost always get your primary key being your cluster key. Inside your non-leaf levels, what's stored there is your cluster key, and then obviously pointers to other nodes. The leaf level contains data pages. This is what you actually think about whenever you think about your data. It contains the cluster key for that row plus any non-key columns. So if I had a table, let's say a customer table, and I had a clustered index on customer ID, my non-leaf levels would contain customer ID, and my leaf levels would contain customer ID plus first name, last name, on and on, whatever you have in that table. So what I want to do, now that I've explained a bit about what a clustered index is. Remember, if you have a clustered index, that's your table. Another rule to keep in mind, this is kind of a trick question sometimes you'll see, how many clustered indexes can I have on a table? I hope that you're thinking one. I can only organize my data one way, so one. Another thing that I like to think about with clustered indexes is compare a clustered index to a phone book, even though we hardly ever use phone books anymore. But if you have a phone book sitting at home that you haven't thrown in the recycle bin yet because you probably don't use it, you can, if you page through that, the white pages are organized as a clustered index. The book is there. Every item that you want can be found based on last name. So that last name is the cluster key. And actually probably last name first plus first name is the cluster key for a phone book. And that's, to me, one of the best representations of a clustered index, because the book is itself, how is it organized? It's organized by that key. Hopefully that makes sense. We can have only one clustered index on a table. The clustered index is the table, and the non-leaf levels store the cluster key. The leaf levels contain the data pages, which is the cluster key, plus your non-key columns. So I want to tell you a few things about the best way to design your cluster key. And there's several good practices, and like anything else, you could never 100% follow best practices. They should probably just call them best suggestions, because there's always going to be some edge cases that don't fit. So if I have my data, the same data we've been looking at, and it was inserted, the M was inserted, then the S, then the D, then the X, SQL doesn't just rearrange everything. It has pointers pointing at these rows. Okay, so I mean that would really be nuts if it had to completely rearrange. You do have to rearrange these pointers, and that's not necessarily good. So what I'm saying is it's better if your cluster key is based on how your data is going to be inserted. So for example, let's say you have an identity column on your table. That would be a pretty good candidate for your cluster key, because your rows are going to be inserted in the order that of the cluster key. The cluster key will create pointers all over the place if it has to, but if you go ahead and insert your data in the same order as the cluster key, you'll have a lot less problems with fragmentation. So let me show you what happens. So after I have my X, I'm going to insert an A, and A's got a pointer to D. Now I'm going to insert a T. Well, you can see a problem. T is actually between S and X, so I'm going to create a pointer to X, remove the pointer from S and X, and then point to T. Then I've got an F, so then I've got, rearranging pointers again. So you can see that we're starting to have kind of a crazy problem here, and that's called fragmentation. Fragmentation is going to make SQL Server work harder to return the data that you need to see. SQL Server works harder, performance goes down. The next thing to keep in mind about the cluster key, cluster index, is that the cluster key should be narrow and it should be unique, or a high degree of selectivity, meaning if I picked a cluster key on a true-false type column, a bit column, that would be a really bad cluster key, because I would have half of the values with a 1 and half of the values with a 0.